Hello, I'm Professor Rad, and today we're going to talk about using multiple different operations with fractions. So as a reminder, with all the different types of numbers we've discussed, our order of operations can be remembered using the word GEMS. So G stands for grouped operations, E stands for exponents and radicals, M for multiply and divide left to right, and S for subtract and add left to right. So we're going to work through 3 examples. Now, each of the different types of operations for fractions have, different techniques for them. So now more than ever, separating out like the main problem from our scrap paper is going to be important to kind of keep all of our work clear. So let's start out with 7/8 plus 2/5 times 15/16. And as a reminder, I'm going to put a note to myself. Let's use GEMS. And I'm going to draw a line here to separate out my main problem with the work for each of the individual steps. Okay, so grouping symbols. I don't have any brackets or parentheses, so there's nothing grouped. Exponents. I don't have any exponents here, so we're going to skip that. Multiplication and division. So I have adding and multiplying. So we've got to do this multiplication step first. So step 1 is going to be 2/5 times 15/16. Now, I want to be in the multiplication zone. So in the multiplication zone, we had 2 techniques. You could either multiply across and then simplify, or you can use the prime factorization method, which involves factor trees and then canceling out common factors. So for this one, because I don't want to carry out a lot of larger number multiplication, and by larger I mean these 2-digit numbers, I'm going to go ahead and use that prime factorization technique. So I'm going to find the prime factorization of each number. 2 and 5 are each prime, so I don't have to worry about that first one because I've already got prime numbers. 15 is the same as 3 times 5, and both 3 and 5 are prime. So I'm going to write 15 as 3 times 5. And then 16 I'm going to make the factor tree for. So I know that 16 is 8 times 2. 2 is a prime number. And 8 is the same as 2 times 4. And 4 is the same as 2 times 2. So this means that 16 is going to be the same as 2 times 2 times 2 times 2. All right, now we can go ahead and cancel out our common factors. So we have a 2 in the top with a 2 in the bottom, and we have a 5 in the top with a 5 in the bottom. And just a reminder, we can't cancel these 2's because they're on the same side. They're both on denominator. This is going to leave me with a 3 in the numerator, and then 3 2's. So 2 times 2 is 4. And 4 times 2 is 8. So all of this work here is telling me that 2/5 times 15/16 is 3/8. So I can go back into the main problem, and we did this multiplication and got 3/8. Now I'm going to carry down what we had over here. Now, and this is very important for me actually, I like to stop and breathe because especially when the operations are difficult, you can start to like hold your breath and get really tense. So, okay, we just did this one operation. We're going to clear out the mind and focus on what we have here. So now we have an addition problem. So for step 2, we're going to add. In fact, I'm going to draw a little division here so that I don't get distracted by that work up there. And we have 7/8 plus 3/8. Okay, so now I need to get into the addition zone. In the addition zone, I need a common denominator in order to add. This is because I'm going to be adding the amount of pieces, and I want all of those pieces to be the same size. So fortunately for us, we've got a common denominator here. So when we add, we keep the denominator the same. All of our pieces are eighths. Remember that denominator is like a unit. And then we just add the tops. So 7 plus 3 is 10. Now I want to simplify my answer. And I notice that both 10 and 8 are even numbers. So I'm going to divide both of those by a 2. 10 divided by 2 is 5. And 8 divided by 2 is 4. 5 and 4 have no other common factors, so that's going to be it. This will be our simplest form. So back to my main problem. When I added those two fractions, we ended up with 5/4. Now, let's go ahead and use a calculator to check our answers here. So I'm going to bring in the old standby, the TI-36X Pro. And let's go ahead and type in the original problem. So we had 7/8 plus 2/5 times 15/16. Then we'll press enter, and we get 5/4, which is what we got here. Yes, I always like when that works out. Okay, let's go ahead and do another one. Okay, so for my next example, we're going to simplify, which just means carry out all the operations. 1/4 divided by 3 minus 1/2 times 5/6. Oof. Okay, so one thing at a time here. Let's write out GEMS as a reminder to ourselves of our order of operations. Then I'm going to, I'm going to copy this question off to the left a little bit. 1/4 divided by 3 minus 1/2 times 5/6. Okay, so that's where I'm going to keep my main problem. And then I'm going to do all of my scrap work over here on the right. So, GEMS. The G stands for grouping symbols. So I don't see any parentheses or implied grouping. So I move on to E. This is for exponents. We don't have any exponents. M. M stands for multiply and divide left to right. So we've got some divide and we've got some multiply. So we're going to work left to right. So I'm just going to focus on this piece first. I'm going to bring that over to the scrap side. 1/4 divided by 3. Okay, cover up the big scary problem and let's just look at this single operation. So we're doing 1/4 divided by 3. First thing I notice is that I've got a combination of fractions and whole numbers. So let's make this whole number a fraction by putting it over 1. So everything's got kind of the same format. Now for division, I'm going to remember keep, change, flip, or multiply by the reciprocal. So I'm going to keep the 1/4, change divide to times, and then flip my second fraction to be 1/3. Okay, so we just went from dividing into multiplying. So when we multiply, we can either multiply across and then simplify, or we can use the prime factorization like we did in the last problem. On this one, because the numbers are all pretty small, I'm going to use the multiply across and then simplify. So 1 times 1 is going to be 1, and 4 times 3 is going to be 12. Now, remember, if you have a numerator of 1, you need to keep it there. And the only thing that goes into 1 is 1, so this is in simplest form. So 1/4 divided by 3 gave us 1/12. So I'm going to go back to my main problem and replace this piece with 1/12, and then copy down all the rest of this. Okay. Important step, make sure you breathe. Okay. So kind of clearing my mind of that work that we just did because it's done. We don't need to hang on to that in our short-term memory. And now I look at this new problem. We have subtraction and multiplication. So multiplying comes first. So I'm going to do this multiplication piece before I do any subtracting. So for step 2, I'm going to do 1/2 times 5/6. Cover up that work because we don't need it right now. So for multiplying fractions, put myself in the multiplication zone. So I could either multiply across or I could use prime factorization. Once again, these numbers are pretty small, so I'm just going to go ahead and multiply across. 1 times 5 is 5, and 2 times 6 is 12. Now, there's no number other than 1 that divides both 5 and 12, so this is our answer in simplest form. So back to the main problem, we're going to throw this 5/12 in that we just found. And then I'm going to recopy the rest of the problem. Cool. Get rid of this. Now all we have left is subtraction. So let's bring that over here. 1/12 minus 5/12. Okay. For subtraction is like addition, so that means we're going to need a common denominator, which, hooray, we have. So we are going to keep that denominator of 12. And now we have to subtract the tops. So we have 1 minus 5. Okay, so I have a smaller number minus a bigger number. So I could think of that as I've got $1 and then I take $5 out of my account and then I have a negative $4. Or you could do keep change. 5 minus 1 is 4. And the bigger number, the 5, was negative, so we get a negative. Or any other technique that we have for subtracting integers. Whatever we use, we're going to get negative 4 as that numerator. Now let's check to see if we can simplify. So I recognize both the negative 4 and the 12 are even, so we can divide both of those numbers by 2. Negative 4 divided by 2 is negative 2, and 12 divided by 2 is 6. All right, so it looks like I'm not done yet because both the 2 and the 6 are even. So I'm going to divide those by 2 again. Negative 2 divided by 2 is 1, and 6 divided by 2 is 3. Oh, wait. Negative 2 divided by positive 2 is negative 1. There we go. And positive 6 divided by positive 2 is positive 3. So that's going to give us this negative 1/3 in the end. Coming back over to the main problem, when we worked through the subtraction, we got a negative 1/3. So that's our answer. Whew, okay. So we've just simplified this fabulous expression one step at a time. Now, let's use our calculator to check our final answer and see if we got the work right. So I'm going to do 1/4 divided by 3 minus 1/2 times 5/6. All right, cool, we got a negative 1/3. So that matches. Okay, now you might be wondering, Professor Ad, why do we have to do all of this by hand when, look, the calculator does it, right? No mess, no fuss. So there are a couple of reasons that it's worthwhile to work through this by hand. One of those reasons is if you're going into algebra, the techniques for algebra, meaning if we had letters tossed into here, those techniques are going to be very similar to these techniques by hand. So if you're going to build algebraic reasoning, having this as a foundation is very helpful. The second reason is even if you're not going into algebra, let's say you're going to take statistics next semester. So if you're going into, say, a statistics class, you won't necessarily need to do this kind of work, but a lot of the problems that you'll find in statistics are long and require many steps. They require you to have to make very subtle identifications in order to determine what process to apply or what formula you're going to use. And we're developing that skill in this question. In this question, we are applying our order of operations to identify the order in which we complete steps, and that's going to be important in statistics. You'll need to know an order in which to complete steps. Then, in each of our steps are all involving fractions, but they all have their own different quirks to them. If I'm dividing, I have to do one thing. If I'm multiplying, I do one thing. If I'm subtracting, I do this other thing. So each time we have things that look very similar, but one difference, each of these operations, is going to change what we do to get the solution. And that's true in statistics too. Very often you'll be looking at two scenarios that are very similar, but let's say you might have to identify whether or not the standard deviation you have is for a sample versus a population. So you have to make an identification between two things, and then depending on what you know, then your process can be different. So depending on what operation we know, our process is different. So that's a skill, a really important skill that we're developing here for problem solving, identifying subtle differences and then carrying out complicated processes in the context of this own other complicated process. So we're using the operations to help us develop that type of thinking, even if we don't end up using these specific processes in the future. Okay, so let's do one more example of developing this mathematical chutzpah, if you will, this mathematical integrity, and then we'll have a Now You Try. Okay, so we've got 24. In fact, you know what? I'm just going to copy this down instead of just reading it. We've got 24 with this big old parentheses, 17 over 6 plus 3 over 8. So that's my main problem. Going to divide out my scrap work on the right, and I'm going to write gems to help me with my order of operations. Okay, so let's look at what we have. We've got, sorry, I just hit the table. We've got 24. And then, as a reminder, when there's nothing in between a number and parentheses, do you remember what operation that is? It's a multiplication. So I'm going to write that in so I remember that. And then in our parentheses, we've got an addition problem. So Gems says, do you have any grouping symbols? And yes, we do. So we've got to do the grouping things first. So I'm going to write out my 17/6 plus my 3/8. Cover that up and just zero in on this first step. We have addition. Addition requires a common denominator. And right now, my denominators are not common. Wah, wah. So I have to think about the different techniques that I like to use to find a common denominator. So I could multiply the two denominators, or I could try and find the smallest common denominator. in this case, I'm going to just go ahead and use the direct approach. I'm already like overburdened with all these operations going on. So I'm just going to be like the most direct for this operation. So I'm going to get a common denominator by multiplying these two. So 6 times 8, that's going to give me 48. So now I have to rewrite each of these fractions so that I have that common denominator. Okay, so 17/6, rewrite, times something gives me this with the 48. And then 3/8. 3/8 times something gets me that 48. Okay, 6 goes into 48 8 times. So I'm going to put 8 on the bottom and also the top. 8 goes into 48 6 times. So I'm going to put 6 on the bottom, 6 on the top. Okay, 17 times 8. Okay, 8 times 7 is 56. 8 times 1 is 8, plus 5, 9, 10, 11, 12, 13. Okay, so we get 136 for our numerator here. Fortunately, the second one had a small numerator, so 6 times 3 is 18. Okay, why did we do this? So we got a common denominator because we're trying to add. Okay, so 17/6 was 136 over 48. And 3/8 was 18/48. Okay. So now we have this common denominator of 48. Let's go ahead and add the numerators. So we've got 136 plus 18 gives me 14, 3, 4, 5, and a 1. So we get 154. And this is over 48. Whew, okay. Let's see if we can simplify, yeah? So we've got even numbers on both the top and the bottom. So I know that 2 is going to simplify these numbers. So let's divide the top and the bottom by 2. Two goes into 15 7 times. 7 times 2 is 14. Subtract and get 1. Bring down the 4. 2 goes into 14 7 times. 7 times 2 is 14. And there's no remainder. Okay, so that means 77 is going to be the numerator. And then 48, do over here, divide that by 2. 2 goes into 4 twice, since 2 times 2 is 4. And I don't get anything back. Let's bring down that 8. 2 goes into 8 4 times, and 4 times 2 is 8. I get no remainder. Okay, so 48 divided by 2 is 24. Okay, let's see if we can keep simplifying. So 77 is a number that I know only 7 and 11 are going to go into 77. I know 7 doesn't work in 24, and neither does 11. Whew. Done. Except I'm on my scrap paper side. That means I'm not done. That means that was just step 1. So all of this is step 1. So we are definitely building up some mathematical stamina here, some chutzpah. So let's go back over here. we did the 17/6 plus 3/8. So that was this piece. That's our 77 over 24. Then let's bring down that times and the 24. Oh my goodness. Okay, let's breathe for sure. Okay. Let's go ahead and put that 24 over 1 so that we just have fractions. And we only have one operation left. We've just got this times. Now, I'm going to be real. I'm looking for shortcuts at this point because I'm a little exhausted now. And the good news is there is a shortcut available to us. We can kind of use that canceling technique without having to find a prime factorization because 24 up top can cancel with 24 down below. So I don't actually need to multiply anything. I can use the same concept from our prime factorization method of multiplying by just canceling those two common factors since it's the same up top and below. That gives us just 77 up top and a 1 in the bottom. And if I have a 1 in the bottom, I don't need it. We get a whole number answer. Ta-da! Okay, so first step, very arduous, very time consuming. But the second step, actually not too bad because we had this little cheat code here. So if we didn't have that little cheat code, then I would have to multiply like we did in the previous examples. All right, so that's it for this video. I do have a couple of Now You Try problems for you in case you want to practice some more finding this order of operations with fractions by hand. In the next video, we are going to look at that last example in particular again. So examples that kind of look like this one. And we'll apply a property to help us cut down that work a little bit. So looking forward to seeing you in that video. In the meantime, have a great day. And remember to breathe.